In this short video, we're going to be going through a very important proof, and that is by contradiction. And so you see, the thing is that for some proofs that we've shown you before, we can actually do a direct proof via algebra. But there are some things, such as if I want to prove that root 2 is irrational, root 2 is irrational, which we basically say, or if I wanted to prove that a triangle cannot have more than one right angle, or if I wanted to prove that a tangent to a circle and the radius of the point and the contact will make a right angle, these are the sort of proofs there we can't actually do it directly. We need to actually do what's called proof by contradiction. And the premise for the proof by contradiction is this. To prove a statement by contradiction, what we have to do is we have to assume the statement that you are trying to prove is actually false. So we assume that it's false. Now, if you then, through your working logically, find, and from your assumption, find that you can produce a mathematical contradiction. Now, when I went to university, whenever I saw a mathematical contradiction, I was told to do this little lightning bolt thing. That actually means that that's the contradiction. That line of working is a contradiction. And if you did that in your exam, perfectly fine. I'd be wrapped with that. Okay. So if you find a contradiction, then hence conclude that the statement you are trying to prove must be true. So if you think about it, it's like a double negative, isn't it? I assume that something's false. I prove that that's false. So therefore it must be true. Okay. Now, Ben over there gave me this whole circular logic, and it really did get you, didn't it, Ben? It really did. It really just like spun his whole head and things. So let's just start with some really basic ones, okay? And as you can see here, can everyone, and I hope that if you're in specialist maths, you can see that the square root of A plus the square root of B is not equal to the square root of A plus B, okay? So if I was to do this, what we're going to do is I want to prove by contradiction. So what do we have to do? We have to assume the opposite. Now we're trying to prove that it's not equal to. So we therefore assume that it's equal to, okay? So what we're going to do is we're going to assume that root A plus root B is the opposite, is equal to the root A plus root B. Now what we're going to do is we can just do this. We can just say, let's look at the left-hand side, let's look at the right-hand side, and if there's some contradiction, therefore, the opposite must be true. So what we're going to do is I'm going to do the left-hand side. I'm going to say that, so what we're going to do is, so I've got, if I do that, why don't I square both sides? Okay, why don't I actually square both sides? So if I square both sides, that's going to be root A plus root B squared is equal to root A plus B squared, like so. Now, if I then, that's going to be root A times, well, let's do it over here. Let's do it over here. Root A plus root B, just so we don't make any algebraic mistakes. Root A plus root B, so that's squared. And of course, we know the right-hand side is just going to be what? A plus B, isn't it? A plus B. So let's go across here. Root A times root A is going to be A. That's nice. And root A times root B is root AB, isn't it? We've got another root AB, like so. And then we've got root B times B is B. Now, A plus B. Now, that's going to be, so A plus 2, now there's 2 of them, isn't there? There's 2 lots of them. So we've got, that's 2 root A, B, plus B is equal to A plus B. We could even say that we can even cancel these out, and we can say that 2 root A, B is equal to 0. But haven't we just found a contradiction? Because what is the assumption that we've made? They aren't 0. So how could that possibly be the case? Because A and B are non-zero. So therefore 2 root A, B can't equal 0, can it? So there's the contradiction. Or you could write contradiction, but if you do a lightning bolt, that's fine, okay? That's just how I was shown in university when I was doing advanced proofs and stuff like that. So therefore contradiction. So therefore now we've found the contradiction, we can now therefore say that therefore the opposite is true. Root A plus root B is not equal to root A plus B. So you start off with assuming the opposite, finding a contradiction, and then of course making your final statement. Okay, and look, people might write QED, as I said. But you know what? Therefore, this is not equal. That's fine by me. Okay, now let's do the same thing. The same thing applies for this one. A plus B all squared is equal to. So what are we doing? We assume that A plus B all squared is equal to A squared plus B squared. And of course, you guessed it, you can finish it off with me. That's fine. That's going to equal that. And there's going to be some contradiction there. A squared plus AB plus AB again plus B squared is equal to A squared plus B squared. Now, even then you can see, since A and B, that's the important thing. Since A and B can't be 0, well, we could do some cancelling out here, okay? And then we can say that's 2AB is equal to 0. Oh, no, that's a contradiction. So therefore we can say that since A and B cannot equal 0, we can then therefore say that A plus B, the opposite, we've just proven that by contradiction, A plus B all squared does not equal to A squared plus B squared. Does that make sense? The problem is it gets a little bit harder with some of these other ones because it's not about necessarily the algebra, it's about the assumption, okay? So this one is a typical one, okay? Proving that something's irrational or proving a log is irrational, okay? But so what I'm going to do, we're going to do this together. Now let's have a look at this question. It says, prove that root 2 is not a rational number. Now, first of all, when I'm talking about rationals, have you guys seen this before? Q, what does that mean? Rational. So what we're actually proving that root 2 is an element of real numbers that are not rational. Does that make sense? There's no way of writing irrational. It's real, but it's not rational. It's irrational. Now, technically then, root 2 then, what we're trying to do is root 2 is not equal to A over B. Okay, such that A and B are both integers. And how do we write integers? Z. Very good. Very good. This stuff, although it's not in year 12, great for your mathematical notation, which, by the way, a big part of methods is good notation, and this sort of function notation and all of these sort of things. It's dynamite. Okay, so it's actually it's a really useful thing. So what we're trying to prove is that root 2 is not A on B. Now here's the thing. Here's the kicker though. Prove that root 2 is not a rational number. So that's sort of over here. That's what we're trying to do. And that is root 2 can never be written as A over B, where A and B are both integers. Integers, okay? So if we go ahead and we find out and we work this out and we assume the opposite, that it equals A on B, so we've got to prove, let's set it out. We've got to prove that root 2 is not equal to A over B, such that, and I'm writing it out again, A and B, element of Z. Or if you wanted to write it out in words, just like it is above, perfectly fine, I'll accept it, okay? So your proofs are going to look different, all right? If you want to copy my method, great, okay? There's probably usually a method behind my madness. Madness behind my method? I don't know. But anyway, I'm trying to show you my way of doing things, because often, yeah, I can guarantee you're not going to lose a mark in a test or an exam if you do it this way. So please don't invent your own methods, but yes, they can be slightly different. There's no doubt about that. So what do we assume now? We're trying to assume what? Well done. So we're going to, and we've got to use English. We've got to use English. Now, my international student friends, last year, a lot of you did a bunch of algebra without writing clear, logical English, and you didn't get the marks. Might have only got 2 out of 4 marks, and that was a bit of a trend. Okay, the students that English was their first language, they did a hell of a lot better on these questions. But you really need to watch this video prior to the exam and make sure you study it, please. So we're going to assume that root 2 is equal to A on B. Follow me so far? Okay, so what we're going to do now is we're going to do a little bit of something else. We're going to square both sides. Okay, so let's square both sides. So that's 2 is equal to A squared over B squared. So therefore, we can say that A squared, let's do A squared is equal to 2B squared. Now, the problem is that, so therefore, what can you tell me about A squared? A squared must be, think about it, what's the definition of an even number? Yes, is this a multiple of 2? So this is even. And if you know what, if you did that, a little arrow and even, I'll let you do it. You know what I mean? It's all good. It's not necessarily. So we can say that A is equal to 2K. Yeah, that's like basically saying A is equal to 2K, which is even. Okay? K is sort of any integer. All right. Now, this also means that, what else have we got? This means that A squared is also equal to 4K squared sort of thing, and therefore 4K squared is equal to 2B squared, which implies that B squared is also equal to 2K squared, which is also what? Even. So B, so B squared is equal to 2K squared, which makes that even, doesn't it? So therefore, B squared must be even. Therefore, B squared must be even. Okay, now, since we've established, since A and B are even, contradiction. Because if I have 2 even numbers, haven't I just found they're a fraction? like that would be a fraction. Yeah. So by this contradicts our assumption that the fraction a and b cannot be simplified. The whole point is, what I've missed here is that a over b cannot be simplified. Okay? If I have an even number, 4 and 6, can that be simplified? Yes. So therefore, by extension, so hence the assumption is wrong. Therefore, root 2 is irrational, and you can write it even in English is fine. Okay? Now, there's some other ones I'd like you to do. I am going to stop there, obviously. But I hope that gives you, that 15-minute video gives you a good idea on what to expect. And if you do the coursework, especially the ones we'll go do some logs later, that would be pretty much setting yourself up for the exams. Make sense?